Welcome to IB Chemistry exam preparation, exam tips for both standard level and higher level. Through this lesson, we're going to complete chapter number 6, Kinetics, Rate of Reactions for standard level. This lesson would be part number 4 to complete the chapter. In this lesson, we're going to learn how to apply on factors affecting the rate of chemical reactions. I'm going to start with a question. In this question, we're going to see how the factor that will be changed inside the experiment will affect the curve when we're going to apply on it. According to the question, magnesium in excess is added to X cubic centimeter solution of sulfuric acid of 2 mole per decimeter cube. In this example, we have magnesium, which is added to the sulfuric acid H2SO4. In any question, there should be an excess reagent and another limiting. According to this question, the excess it is for the magnesium, and the limiting is for the sulfuric acid. When these two reactants are added together, of course, there will be a single replacement reaction, and this will form at the end the hydrogen gas besides the salt magnesium sulfate. The volume of the hydrogen gas which was produced was followed within the time, and the following graph was drawn. So if we look at the graph, we're going to find that on the y-axis we have the volume of hydrogen gas that was collected, and we have on the x the time in minutes. According to the question, we need on the same graph to draw the curves that we would expect if the same volume, X cubic centimeter of 1 molarity H2SO4 is used. So in this question, I have another new concentration that has been used. So instead of using 2, we changed the concentration into 1. So through the following slides, we're going to learn how to apply on such these questions. Before drawing any new curve, firstly, we need to answer a very important 2 questions. The first one, we need to start thinking about what happens to the rate of reaction. In order to answer what happens to the rate of reaction, this can be answered based on the factors that affect the rate of chemical reactions that we previously studied. Considering these factors, I have number 1, the concentration factor, number 2, the temperature factor, the surface area, if I have a solid reactant, of course, and I have the addition of any catalyst. Now, after answering what happens to the rate based on one of these factors mentioned inside the question, I need to go through the second question, which is what happens to the total volume or the total property collected on the y-axis. So it's actually what happens to the ending part of my curve. To the ending part of curve. For this question, we need to be familiar on 2 things. Number 1, in order to answer this question, you need firstly to specify whether the reactant is a limiting reactant or excess. If the reactant was in excess, so there will be no change in the total property collected. So if according to the question, the concentration of an excess reagent or the surface area of an excess reagent has been changed, this indicates that the total property will not be changed at all. So it will be the same ending for the curve. Now, if the reactant was a limiting reactant, this is the second situation. So we need to consider the calculations of mole number of this limiting reagent. If the mole increases, then the property will actually increase. But if the mole number decreases, then the property on the y-axis, it will decrease. Now we're going to see how can we apply on these 2 questions. Going back to the original question, Magnesium in excess is added to x cubic centimeter solution of sulfuric acid. So another time, it's my magnesium that is added to the H2SO4. Here I have the volume, which is x cubic centimeter according to the question. And I have the concentration, which is actually 2 molarity. And of course, the magnesium is the excess, while the H2SO4 is considered my limiting reagent. Now, the same volume, x cubic centimeter of 1 molarity H2SO4 is used. So let's start answering the questions. What happens to the rate of reaction? Definitely the rate, it will decrease. So it will become slower. And this is because of the change in concentration. So since the concentration of H2SO4 decreases, and this is related to the collision theory and the frequency of successful collisions. Now for the second question, what happens to the total volume collected on the Y? Now the change that takes place, it is for the H2SO4. And H2SO4 is actually a limiting reagent. So this is a limiting reagent, so I need to look for the mole number. I'm going to calculate the mole number as before and after. So mole before, and I'm going to do the mole after as a change. Now, for the mole before, we need to remember that the mole number, it is concentration times volume. So my concentration, according to what's given in the question, it was a 2, multiplied by the volume, which was x cubic centimeter. No need here to convert into decimeter cube, as we are only doing comparison, and it is a constant number. So this final answer, it is 2x mole. Now we're going to go through the mole after. We will apply on the same rule, taking into consideration the change in the concentration, which is 1 instead of 2. So it's a 1 multiplied by the same volume, which is x. So here I have x mole number. So by this simple calculation, I can find that the mole of the limiting reagent decreases. So mole of H2SO4, it actually decreases. It becomes smaller. So this will definitely affect the total volume collected. So total volume of hydrogen gas, it will also decrease. And this will affect my ending part of the curve. Since the limiting reagent mole number, it becomes smaller, so the hydrogen gas that will be collected according to this experiment, it will also decrease. Let's apply on these two questions and answer. According to this graph, I'm going now to redraw my new curve according to the change that takes place. As we previously said that the rate of reaction, it is slower. So you need to start with less steep. So you need to start with your new curve below. It should be less steep. It's slower. So you need to start it from below. But if it is within a higher rate of reaction, so you need to make it steeper. So you will start from above of your original. I'm going to erase the above. And we're going to continue by below part. Now, so it's a smaller rate, slower rate, and less steep curve. And you're going to have smaller volume. So you're going to find it as having smaller volume compared with the original one. So we're going now to see what would happen in order to make it to end below the original. So this would be like this. And it should be below the original. So this is your answer for I. As an explanation, the curve is less steep since the reaction rate decreases due to the decrease in the concentration of acid reactant, and the total volume of gas collected was smaller since the amount, which is the mole number of the limiting reactant, which is the sulfuric acid, decreases. So these 2 points, as an explanation, they are the 2 different questions that we previously answered. Now we will apply on more questions. Let's go to double I using the same reaction, which is magnesium and sulfuric acid. Double I, double the volume, 2x cubic centimeter of 1 molarity H2SO4 is used. Let's start with the rate of reaction. So the rate is actually affected by the concentration. The volume will never affect the initial rate of reaction. So no matter what's the volume, could be triple, could be halved, could be quadruple, it will not affect your rate. The rate is only affected, and remember that, by the factors which affect the rate of reactions, considering the concentration, the temperature, the surface area, and the catalyst effect. So what happens to the rate? Actually, the rate, it will decreases as the concentration decreases. I'm going to write here a small note to remember. The volume change do not affect the rate of reaction. So the volume of an aqueous solution will not affect the rate. We have actually one situation into the volume would affect this. This is in case of having chemical reactions which are made of gases. If there is a gas, so the volume change will affect the pressure. So in somehow the rate of chemical reaction will be affected. But if I'm talking about aqueous solutions, the volume, no matter what's the volume change taking place, it will not affect your rate. It's the concentration actually. Now what happens to the total volume? Another time, I'm going to calculate the mole before, and I'm going to compare it with the mole after. The mole before, it's of course the same rule, concentration times volume. I'm using the 2 multiplied by my volume, which is x. So this is 2x mole number. Now for the after, the concentration is 1 multiplied by 2x. So the volume, it was doubled. So it is 2x as a mole. What can you conclude if you compare the mole number before and after? You're going to find that both of them, they have exactly the same. So no change in mole. This definitely means no change in the total volume collected or in the ending part of the section. Ending of curve. So when you're going now to apply on double I, and we're going now to answer the question, we need to have a slower rate, but it should end at the same exactly volume. So it's the same ending. It's not below it as I. So this is your double I. As an explanation, for the first question, the curve is less steep since the reaction rate decreases due to the decrease in the concentration of acid reactant, so less collisions per unit of time. For the second point, the total volume of gas collected is the same since the mole number of the limiting reactant, which is the sulfuric acid, didn't change, and we proved that by calculations. Now I'm going to go through another triple strand. The same volume, x cubic centimeter of 2.5 mole per decimeter cube sulfuric acid has been used. So starting with the rate, since the concentration of the sulfuric acid, the limiting reactant, increases, so the rate will definitely increase. So the rate of reaction increases. So we need to remember that we need steeper curve. When talking about steeper, so it should be closer to the y-axis, since the concentration of the sulfuric acid increases. Now, what happens to the total volume? Let's do the before and after. Now, the before mole number we calculated previously several times, so it is 2x mole. For the after, I'm going to go through the change. So mole equal your concentration times volume. Your concentration is 2.5 multiplied by the volume, which is an x, and your final answer is 2.5 x mole number. Now from this part, we're going to find that the mole actually increases. So the mole of limiting reagent, which is the H2SO4, increases. So this indicates that the total volume collected will increase as well. So the total volume will also increase. So when you're going now to draw, you need to end your curve above your original. So I'm going to have a steeper curve since it is faster rate of reaction, so it will be above your original. And you should have it as larger volume. So it should be above your original. So this is for your answer in triple. Now, as an explanation, the curve is steeper since the reaction rate increases due to the increase in the concentration of acid. The total volume of gas collected is larger, so it's above the original curve, since the amount, which is the mole number, of your limiting reactant increases as well. I have now 4. Using powder magnesium instead of large lumps with the same mass. Here we need to remember that the magnesium is in excess. This would affect our decision in number 2. So we need to make sure that this reactant or reagent is actually in excess. So the excess part, it will affect the total volume collected on the Y. We should answer whether it is a limiting or excess inside our mind. Okay, so what happens to the rate? Talking about powder, so surface area increases. Becomes larger surface area due to the use of powder, smaller lumps. So surface area increases. Therefore, what will happen to the rate? Definitely the rate will also increase. So the rate of reaction increases. So the curve should be steeper, closer to the y-axis. Now, what happens to the total volume collected? Since magnesium is in excess, it will not affect the volume collected. So it's the same ending. So anytime you have an excess reagent taking place, it would affect the rate of reaction. So it could affect the starting part of your curve, but it will not affect at all the total volume collected, since the same hydrogen amount of gas or the same property, it will be at the end measured. So from here, I'm going to draw the rate which is faster, so steeper, but it should be the same ending. So my new curve, it will be like this. So this is my 4 as an answer. Okay, now we're going to go through V. The temperature of the reaction decreases. Of course, the temperature, it will affect the rate of reaction. So since the temperature decreases, the rate, it will become slower. So the rate of reaction will decrease as the temperature decreases. Of course, this is related to Maxwell-Boltzmann distribution curve, as the probability or the fraction of particles with energy higher than or equal to the activation energy will decrease, so less frequency of collisions, and this at the end will end up with a slower rate of reaction. Now, what happens to the total volume? The temperature will never affect the total volume, so it will be the same ending. So temperature and actually the catalyst will not affect the total volume. So temperature change never affect the total volume collected. So same ending. Okay, I'm going to have less steep, and it's the same ending exactly. So this is for V. Now, if you have a catalyst was added to the reaction mixture, what happens to the rate of reaction? Of course, when a catalyst is added, the rate will increase. So the rate of reaction increases as the catalyst is added. When adding catalyst, it lowers the activation energy and provides alternative pathway for reaction. Besides that, according to Maxwell-Boltzmann, also the probability or the fraction of particles with energy higher than or equal to the activation energy will increase, causing to increase the frequency of collisions. Now, what happens to the total volume? The catalyst will never affect the total volume. It's the same ending. So the catalyst will not affect the ending part of your curve. So it's the same volume that will be collected. So now I'm going to have a faster rate. So I need to have it steeper, and it's the same ending exactly. So this is for number 5. Okay, now we're going to apply on some past paper questions taken from paper number 1, multiple choices. 25 degree and 100 cubic centimeter of 1 mole per decimeter cube hydrochloric acid is added to 3.5 gram of magnesium carbonate. If the sample of magnesium carbonate is kept constant, which conditions will not increase the initial rate of reaction? So in this question, I have hydrochloric acid, which I added to magnesium carbonate, MgCO3. According to what's given, I have the temperature, which is 25 degree. I have the volume, which is 100 cubic centimeter. Of course, I'm talking about the HCl. and I have the concentration, which is actually as a 1. So these both, they are for the HCl. And I have also the mass given for the magnesium carbonate, which is 3.5. The question is asking me which conditions will not increase the initial rate. I will actually start with the temperature and concentration, since these both are the factors that directly affect the rate of reaction. So if you look at the choices of temperature, you're going to find that I have 35. Now, if you increase the temperature, definitely the rate of reaction will increase. So C is not the correct answer. Now I will go to the concentration part. The concentration is 1 according to the question. So if you increase the concentration another time, the rate of reaction will increase. So if you look at the possible given answers, you have a 2 molarity and another 2 molarity right here. So definitely, if you increase the concentration of HCl, another time the rate of reaction will also increase. So for B, C, and D, all of them, if you increase the temperature, the rate of reaction will increase. And if you increase the concentration, the initial rate of reaction will also increase. So for the last answer, which is A, as you can see, the same concentration is used, the same temperature is used, and we double the volume. Now, for the part of doubling the volume of HCl, the volume as an aqueous solution, it will not affect the initial rate. Remember that the volume, as we discussed previously, will not affect the initial rate, even if it is doubled. Now, the doubling part, it will affect actually the ending of the curve, as we need to go through the calculations of the mole. So A is the correct answer, which will not increase the initial rate of reaction. Okay, another multiple choice. Equal masses of powdered calcium carbonate were added to separate solutions of hydrochloric acid. The calcium carbonate were in excess. So I have the reaction of HCl plus calcium carbonate, CaCO3, and this was in excess. Now the chemical reaction produces carbon dioxide. Which curve best represent the evolution of carbon dioxide against time for the acid solutions shown in the table below? Okay, I have 3 different experiments. In the first experiment, there is 25 cubic centimeter and 2 molarity HCl. The first thing, I'm going to calculate the mole number of each experiment. So for the first, it's concentration times volume. So I can directly take the volume as cubic centimeter for the comparison, no need to convert. So it will be 25 multiplied by 2, which is equal to 50. I will also calculate the mole number for the second, which is also 50. And finally, I will calculate it for the last one, which is 25. Okay, from the mole calculations, I can conclude that both the 50 and 50 should end within the same ending, same curve ending. But if I want to go through the 25 mole, it should be lower as ending part. Lower curve ending. Another thing, I can also take it according to the 3 experiments taking place, is the comparison of the concentration. If I'm going now to circle the concentration, you're going to find that in the first experiment, I actually have 2. And here I have 1, and here I have 1. So if it's a 2, it should be the fastest rate. Fastest initial rate. And both the second and the third experiment, they have actually the same initial rate. So these are same initial rate. Okay, based on these information, now I'm going to start thinking about which will describe these situations correctly. The answer is considered the C answer. If we look at the C, you're going to find that I and double I, they have the same ending. If you look at I and double I, they have exactly the same ending. And this is actually what we considered before when we calculate the mole number. Moreover, I, it is steeper. Double I, considering the I, it's steeper, right? So it's a faster rate since you have 2 mole per decimeter cube of hydrochloric acid. So this is faster rate. And the double I is slower, and this is actually correct according to the concentration. And for the triple, okay, you're going to find that the triple you will have it as below the original or below I and double I. So it is below it since the mole number is 25. Moreover, if you compare between a double I and a triple, you're going to find that there is something interesting about the initial rate. I will change the color. You will find that double I, this is the green color for double I, okay, and the triple, you're going to find that both of them, they actually have the same initial rate. Okay, it's the same initial. Look at it. And yes, they have the same initial, and this is considered right here. So both double I and the triple, they have the same initial. At the same time, the triple ends below I and double I. So this is a correct curve presenting for triple compared with a double and the I part, which is the first one. So the answer, it's a C answer. Okay, another past paper question. This is an interesting question for one reason, since we have the curve which is drawn as a property of a reactant per unit of time. So there is a decreasing instead of an increase in curves. So curve 1 shows the mass change when marble chips are added to excess hydrochloric acid. Another time the chemical reaction is between HCl and talking about marble chips, so it's a calcium carbonate. Okay, excess is the hydrochloric acid. And here it's my limiting reagent. Curve 1. So this is my original curve. Okay, which changes would produce curve 2? The first thing before starting looking at the answers, I will start thinking about, do they have the same ending? This is a very important question to answer. So if you look at the curve, do they have the same ending? Do they have the same ending? Okay, answer this question. Of course, no. Okay, what does this mean? Since they have not the same ending, so we need to have the change is in limiting reactant. The change should be in the limiting reagent. Okay, so according to the question, it's calcium carbonate. So when I'm going now to start reading the answers, I need to look for something taking place for calcium carbonate, not the hydrochloric acid. So if I start looking at this way of thinking, I will find that doubling the acid concentration will not be a possible answer. Since at the end, the concentration will not affect the ending part. It will only affect the initial rate of reaction. Now, something else, if you look at the answer, we have also doubling the volume of the acid and heating up. Now, if you double the volume, it will not affect the initial rate, but heating up, it will affect the initial. It's actually steeper. So faster rate. But temperature gives same ending. So another time it's not an accepted answer. Now we have two possible answers, A and B. Powdering the marble chips and heating, or powdering the marble chips and doubling their mass. Now, for both, powdering and powdering, the rate, definitely it will increase. And it's steeper, so it's actually a little bit faster if we want to compare from here. Okay, so this is faster, but the point is whether it's rate at powdering the marble and heating, or powdering the marble and doubling their mass. Now, since the curve, it's not the same ending, and here you have curve 2, which is below curve 1, so there is a larger change in the mass of the beaker. So we are talking about a change in the mass of the reactant itself. So you need to pick answer number B. And if you look at the original or the beginning part right here, you're going to find that it's not within the same as curve 1 and 2, and this makes sense since you are not using the same mass. So if you double the mass, and this is in this experiment, we actually have the flask, which is on the balance. So the beginning mass taken here, it will be affected. It's not the same. So because of that, curve 1 started with a mass which is higher than the mass of curve 2. This makes sense actually. And since you are doubling the mass, so you will have more change in mass, or more decrease in mass, let's say. More decrease in mass. So curve 2 was steeper and it was below curve 1, so your answer is B. Now continuing with another past paper question as multiple choice. The dotted line represents the volume of carbon dioxide evolved when excess calcium carbonate is added to hydrochloric acid. So I have the HCl and I have the calcium carbonate. This is your excess reagent. And this is your limiting, of course. Which graph represents the production of carbon dioxide when excess calcium carbonate is added to the same volume? So here I have my change. So hydrochloric acid, I use the same volume. And I have double the concentration. So let's start with the questions. What happens to the initial rate of reaction? Okay, since the concentration increases, and it's a limiting reactant. Remember, it's a limiting. So if the concentration increases, actually the rate will increase. So I need to look through the curve to have something which is steeper compared with a dotted. So it's not B and it's not A at all. So I'm talking about C or D. So steeper. So this is my first question. Now the second question, what happens to the ending part? So the ending of the curve. Okay, let's consider the mole number calculations. So think about it inside your mind since you don't have numbers to apply on. Same volume, double the concentration. What happens to the mole? So mole of limiting, definitely it will increase. So it will be above the original curve. So your answer, it's a D answer. But in a situation of having the same mole number as, for example, if we double the concentration and we have the volume, the mole number, it will not be affected. So your answer, it will be a C answer in this situation. But since the mole number of the limiting increases as the same volume is used and double the concentration is used, So, of course, the ending part or the volume of carbon dioxide would be higher than the original part. So it's a D. Now, this is the last multiple choice question. We have 100 cubic centimeter of 10% hydrogen peroxide. So here the volume is 100 cubic centimeter. And you have its concentration as a percentage. This is percentage by mass, but we can take it as if it's a concentration if you want to make it simple for comparison later. At 298 Kelvin to form water and oxygen. The dotted line graph represents the volume of oxygen produced. Which graph presents the decomposition of half the volume of 20% solution under the same condition? This is a very nice question. Okay, let's start together with looking at the first question. What happens to the rate of reaction? At the beginning, you used 10%. Then we change it to 20%. If I'm going to look at this percentage by mass or percentage by volume as being concentration. So start thinking as if you have 10 and it becomes a 20. So the concentration here, it increases. So the rate will also increase. So this is the first part of thinking. Concentration, it increases due to having higher percentage by mass. So more amount of hydrogen peroxide. Now, is the hydrogen peroxide limiting or excess? We will consider this in the second question. So for the first question, concentration increases, rate increases. I need to have it steeper. So I'm not going to choose neither C or D. So I have now two different options. Now we will go through the second question. Now the second question is what happens to the ending part. Now, is it limiting? This is the point. طبعا hydrogen peroxide, of course, it's the only reactant it presented. So it's limiting by default. So no need even to write this down. It's as a conclusion. So if you've got one reactant, definitely this reactant is your limiting reagent reactant. Now let's go to this question, second one, اللي هي ending part. What happens to the ending? What happens to the ending of your curve? Okay, think about the mole and try to find whether the mole it will be changed or not. If you want to do a calculation part, you can do since we have numbers. If you don't want, you can only think mentally. So before your mole number, I would take the concentration as being 10. So it is 100 multiplied by 10. So it will be 1,000. Now, if I'm going to go after the mole, equal half the volume. So it's a 50 multiplied by 20, which is the same answer, 1,000. So there's no change in mole. So it's the same ending. Same ending. Based on these two questions, my answer, it would be the correct one, B answer. I'm done with our lesson for today, into which we focus on the factors affecting the rate of chemical reactions and we consider their effect on the graph. See you later in another lesson.